To solve this linear inequality, I already have the graph up here, but let me just write the equation down. It's y is equal to 3x minus 5. So really, to start this problem, you would actually graph this line. The reason that it's a dashed line is because we're solving y is greater than 3x minus 5 instead of y is greater than or equal to 3x minus 5. So anytime that you have a problem that does not have the equal sign in the question, it would mean that you're not including the line. So that's how we indicate that with this dashed line. So to graph this, I would just note that the slope is equal to 3 and that the y-intercept has a value of -5. So you really could have started this by, at -5, putting a mark, going over 1 and up 3, and then just drawing the line that goes through those 2 points, and that would be good enough. The next part of this question is, which side of the line are we shading? Are we going to shade over here or over here? So if you look at the original question, we have y is greater than, and a y value indicates up or down. So if you want to say that you're above the line, if you pick, let's say, this spot on the line, greater than means you're going up. If it was less than, you'd be going down. So I already know the answer is going to be everything that is above this line. So everything above it. So I'm just going to shade that in. I'm just going to come through here and mark that like this. Every point that lies in the part that I just shaded is the answer to the inequality. If you want to actually verify that this is true, what you can do is you can choose a test point. That is, you pick some spot in the region that you think is correct and you plug it into the original inequality. So a really easy one to choose here is going to be this point, the point 0, 0. Does that make y is greater than 3 minus 5x a true statement? So what I'll do is, in place of both x and y, I'll place 0 and just ask myself, is this true? And if you simplify it, on the left we get 0, on the right we get -5, and we know that is a true statement. So the point 0, 0 is one for which this is true, in the region that we think the answer is. You could have also picked a point not in the region that is correct. So here's an easy one. How about this spot? This is the point 5 for x and 0 for y. You don't have to do this after you know the region that already works, but this would just be maybe a different way you could approach it. So I'll choose 5, 0 and see if it makes the original inequality true. So this time I'm going to put 0 in place of y. I'm going to put 5 in place of x and just see if this works. When I do this, when I simplify this, I'm checking to see if this is true. On the left we have 0. On the right we have 15 minus 5. And that is 0 is greater than 10. But that's false. That is not true. So several ways you can answer this problem. Like the way I like to do it is I graph the line and I think about, am I above or below it? Another way would be to pick a couple of points. Pick one in either side of the line. The one that works is going to be the side that you shade, and that is it for this problem. For example 2, taking the same approach as in example 1, where our goal is to solve the inequality y is less than or equal to -1/4 x plus 6. And you would start this by graphing the line. I've already given that to you. But just to go through it, the slope is -1/4. The y-intercept is 6, so you'd mark a spot at 6 on the y-axis. A -1/4 slope means you go down 1 and over 4 to the second point, and you would draw the line that goes through those 2 points. Now, since there is an equal sign in the original inequality, that means we are including the line, so the line here is not dashed. And at this point, the answer would just be everything that is below the line. So I'm going to go ahead and just shade that in. So all the points that I've shaded over are in the answer, and everything that is above it is not. So just to go through it one more time, what I'm going to do is choose a point that's in the region. Again, a really easy one would be 0, 0, and just see if it makes the original equation true. So again, we're checking 0, 0. In the expression, y is less than or equal to -1/4 x plus 6. So I'll put 0 in place of y, and then 0 in place of x. Is this true? When I simplify it, I get 0 is less than or equal to 6, a true statement, so I know I chose a point in the region that works. And again, you could use any point that you would like to, but I chose 0, 0 because it's easy. Maybe if we wanted to try a different point, how about this one? 4, 10. I know this point should not work, but again, just to see that, I'll take y is equal to -1/4 x plus 6. I'll put 10 in place of y, and then I'll put 4 in place of x. And when I simplify it, the 4's cancel, so I'm left with just a -1. So that's 10 is less than or equal to -1 plus 6. And if I simplify it, 10 is less than or equal to 5. Okay, well that's false. And that means I would not include that point. So I'm pretty confident that we are actually below the line, and those are all of the points that work. And for the final example, same type of question, but this one has a different starting point where we have 2x minus 3y is less than or equal to 6. Again, we have an equal sign there, which means we are including the line. But now it's not so obvious if we are above the line or if we are below the line. And the reason is because y is not written by itself. To use that logic, you have to solve for y. Or you could just start by choosing a point to see if you think it works. So like, I'm going to take that approach. I'm going to choose a point. I'm going to choose 0, 0. If this point makes the inequality true, I know that this is the correct region. And if it doesn't work for this point, then I just know it's the other region. So I'm going to test 0, 0 in 2x minus 3y is less than or equal to 6. This one's pretty obvious because you have 2 times 0 minus 3 times 0. Is that less than or equal to 6? It is, because 0 is less than or equal to 6. So actually, I know that we're going to shade above this line. If you wanted to take the approach of actually solving for y to see why this is true, let's see what happens. So again, I'm going to go back up to my original expression, and I want to solve this for y. So I'll put this off to the side, but I have 2x minus 3y is less than or equal to 6. I think first I'll subtract 2x from both sides. And I get -3y is less than or equal to -2x plus 6. And now I guess I'll divide both sides by -3. And since I'm dividing by a negative, I know that changes the direction of the inequality. I get y is greater than or equal to, and on the other side, it would break apart into 2/3 x. Again, that's a -2 over a -3, so the ratio is +2/3, but we get -6 over 3, so it's going to be -2. So again, just going back to that quickly here, when I divide this side, I would first divide 2x by -3. So that's where I got the 2 over 3. And then I divide 6 by -3. So the answer itself is going to be negative, and 3 goes into 6 2 times. Well, at this point, y is by itself, and y is greater than. And since it is greater than, it means we are actually above the line. And so that's why the 0.00 worked, because I chose the region that is greater than the line.